Okay, good afternoon. I'm here to go through this practical experiment 3. Okay, so here we go. Now, one thing about all this practical is that it's one thing about being able to do report, but the other thing is that you also have to be able to finish it on time. Okay, you have to finish the whole report, conduct the experiment, the whole report in less than 60 minutes. And you need to plan your experiment first. So actually, the first thing you should do after you finish reading the question is to go to this page and draw in a table. The table should have 7 rows, 6 sets of data, and 1 row of the correct headings. And then after that, you go back to this, you set up the experiment, and then you need to consider for the independent variable, in this case is the x. Consider the independent variable, what is the minimum and what is the maximum. Okay, so when you conduct this experiment, the minimum will be maybe it's very close to this sticky paper. So maybe the minimum is about 2 cm. Okay, and the maximum you can go is very near to the end here, so maybe about 46 cm. So with that, I'll have a range of about 44 cm. Okay, so try to space out your 6 set of data, okay, to be as wide as possible. The rule is that minimally there should be at least 75% of the maximum range. So before I carry out the experiment, so let's plan the 6 set of data for the independent variable. Maybe the first set will be 5 cm, the last one will be maybe 40 cm, and in between put in 4 other data. Okay, so with that and that put in onto the table, you can start to plan your experiment. You can start to carry out the experiment that you have planned. Okay, so that's how you do it. So now, how I'll go through this experiment is first, let me show you a script. Okay, this sample script for marking demonstration. So what I'm going to show you here is not the model answer. The model answer will come at the end. Okay, so just want to show you the thought process as we mark the practical. Okay, so let's look at this script. Okay, the first part. Now remember, the thing about practical is that you're doing an experiment, you have to acquire data. So every data that you acquire, it has to be recorded. Okay, you cannot straight away put in the values or straight away put in the calculated data. Everything that you measure have to be recorded, and anything that you record must be written to the correct precision, and it must have the correct unit. Okay, so let's mark this one. Now first of all, measure and record x. So the way to write it should be x1 equals to x2 equals to. Do not write it in this form, reading 1, reading 2. That is not the way to write. Okay, now let's look at the data. Is the data of the correct precision? I mean, that depends on the unit. And in this case, there is no unit written here. So even here, when you record the data, you have to put in the unit. In this case, it's in cm. It must be included. Okay, so the ruler can measure to the accurate, to the precision of 1 division, which is 1 mm. So if I write it as 5.0 cm, that's fine. Okay, so 5.0 cm, 5.0 cm. So, and then the average data, the average reading should be of the same precision as your measured data. So it is also 5.0 cm, and then you repeat it here. So the first thing to tell you is, please use the correct symbol to denote it, because they ask you to measure x. So don't write things like reading 1, reading 2. Okay, so anything that you record, the unit must be there. Okay, the next thing, this is something new, only seen from this experiment 3 onwards, but you'll be seen very often in subsequent experimental practice. When they ask you to estimate the percentage uncertainty. So how do you do this kind of question? When they ask you to estimate the percentage uncertainty, it means that probably this experiment, your measurement are not taken under ideal condition. They are taken under challenging condition. So when they're taken under challenging condition, the absolute error should not be the ideal data. Okay, it should not be, in this case, 0.1 cm. Okay, now as mentioned in the practical lecture notes, under challenging condition, the absolute error should be 3 to 5 times the ideal situation. So it should be about 0.3, 0.4, 0.5 cm. But how do you score this 1 mark for this kind of question? Take note of every single step I mentioned. Number one, the equation must be mentioned. Delta x over x times 100%. That's number one. Number two, delta x is a judgment. It is not a calculation. Okay, I judge the percentage error to be 3 mm or 0.3 cm, and I write down there 0.3. I do not write it as a calculation. I do not write it as 3 times 0.1. No, it is a judgment. So you put down the judgment. Number three, the final answer, the percentage uncertainty, it has to be 1 SF or maximum of 2 SF. Okay. Now, in this case, it is 6%. So write it as 6%. 1 SF will do. Now, where do you write it as 2 SF? Is maybe if your calculated value is 6.1%, then you can write 6.1%, or you can just leave it as 1 SF. But if you write it as 3 SF, you will be marked wrong. So it requires all these conditions to be fulfilled before you get this 1 mark. That is the rules for practical. Okay, next. You're supposed to determine the period of oscillation. So let's look at this. Now, this is not acceptable because for practical, anything that you record, it has to be clearly written. The marker must know what you have recorded and how did you calculate. Okay, so you cannot just write a formula like that. You must mention, okay, the number of oscillations. So number of oscillations equals to 20. Okay, and you must write down the oscillation time. If t is the oscillation time, okay, t1 equals to 20.8 seconds, t2 equals to 20.7 seconds. So all these must be listed down, okay, because every reading that you take, it must be recorded. When we give you the mark, we have to see the process as well, okay. So only with this, then you write down the equation and the calculation. Okay, now this is still wrong because there's something incorrect here. Okay, uh, the raw data, which is this one, T1 and T2, is of course 1 dp for stopwatch. But the period, you are looking at the SF, not the dp, because the period is a calculated value. So how many SF should it be? Because this is recorded to, when it's recorded to 1 dp, it is actually 3 SF. So for the period, it has to be 3 or 4 SF, not 2 SF. Okay, so this one is wrong. So it should be 1.04 seconds. So this one should be 1.04 seconds. So once again, let me repeat that anything that you measure and record, you have to record it to the correct DP. But anything that you calculate, you have to record it to the correct SF, the significant figure. In this case, it asks you to determine the period. The period is a calculated value. So we look at the significant figures and not the decimal point. Okay, next, let's look at this table. Now, okay, so for this table, uh, the first thing is this: n is not defined anywhere in the question. Okay, if let's say the question, like for example, in this question, you have earlier explained what x is, so that's fine if you just use x. Okay, that's no problem. But n is not defined. The small t was defined previously, so it's fine. But if you did not define previously, you have to define here. That is why this sentence will help. Let n be the number of oscillations, and small t, not period, big T is period, small t be the oscillation time. This sentence must be written down. If not, you'll lose 1 mark for the heading, unless every symbol that you see in the heading has been defined in the question. Okay, so let's check on this table. Okay, independent variable x1, x2, x average. Now, we chose meter. instead of cm, so that's fine. So if it's in terms of meter, remember all these readings are measured using the meter ruler, which has a precision of 1 mm or 0.001 meter. So therefore, if it's meter, all this reading must be 3dp. So correct, and average is also correct, because when you take the average, you have to follow the same dp as the reading. Okay, number of oscillation. Okay, so number of all these oscillation, so that you just write the number there. Remember this n, the number of oscillation is there's no error associated to it, because I mean you're just counting 1 2 3 4 5. There's no precision involved. Okay, now the oscillation time. So the oscillation time here, okay, this is all fine, because all the values, all the oscillation time should be at least 20 seconds. So you must put the number of oscillations such that the oscillation time is at least 20 seconds. So how do you do it? So the first time for this value, I'll do the experiment and let it run. So the moment it hit 20 seconds, then I'll stop at the next oscillation. So in this case is 20 oscillation. Then when I repeat, I also use 20 oscillations. Okay, so that's how it goes. Now, this is the part that you need to take note of. Many students include this column called T average. T average is not necessary. Okay, it is not necessary, because you do not need this column to be able to find the period. Yes, we need the period. The question asks you to put the period, so we need a column that has a period. But do you need this T average? Because the period is basically the average of T1 and T2 divided by the number of oscillations. So this T average column is not necessary. But if you include the T average column and there's no mistake in that column, that's fine. Okay. But in this case, can you see the obvious error? Look. So T average is a calculated value. It should be I mean, it is a calculated value. And you look, all these are written to 4SF, which is one more than the T1 and T2. And then later for the period, you use 3SF, which is the same SF as T1 as T2. So these two columns are using inconsistent principle. So just by adding this T average column, it has sabotaged the correct SF. So if possible, try not to include this column. Okay, stick to T and 1 over T squared. So T, you use 3SF is because all the T1, T2 are 3SF. So 1 over T squared also use 3SF because T1 and T2 is also 3SF. Okay, so now let's move on. So this is for the table. Remember, you only need to repeat for 5 sets of readings, because the first set should be taken from the data of the earlier question. Because when they ask you to conduct it the first time, you see, you use 5 cm and then the period is 1.04. So that should be the first set of data on this table. And then you only repeat 5 more times. Remember, for practical, time is at a premium. You don't have so much time. You can do, if you do 7, 8, 9 sets, it is taking too much time. Okay, so let's move on to the calculation. So this is the calculation part, but of course before you can calculate, you need to look at the graph. So let's plot the graph now. So we are plotting 1 over T squared versus x. So let's look at the graph. So let's check. So first of all, the labeling, the labeling interval must be, you must label at least every 4 cm. So this is labeled at least every 2 cm. So that's fine. Okay, for both the y-axis and the x-axis. Okay, so the first plot is here, the last plot is there, the range, the vertical range, it at least half the graph paper vertically, and the horizontal range is also at least half the graph paper horizontally, so that's fine. The scale is okay, there's no odd scale, so it's like, for example, every cm is 0.1, so that's fine. It's not as if like every cm is 0.3 or 0.7. Things like that would be grossly unacceptable. Okay. Now, axis, no unit. No, this is a serious mistake. You definitely will be penalized. So you might have put 1 over T squared, but then We should be able to read every data from the graph and know what is the correct magnitude and unit. So the unit is absolutely crucial. So it's 1 over t squared s to the power of minus 2. No unit, wrong unit, you will be penalized. So that's for the y-axis, and here for the x-axis is meter. Okay, now let's look at the coordinate. Remember, okay, so this one, it has to be a dotted, yes, if you draw in a dotted manner so as not to confuse with the line of best fit. Where it touches the best fit line, do not put any marking there. So just let it touch the best fit line. Now, how do you write the coordinates? It is compulsory to write down the coordinates here on the graph paper. Now, normally, we'll look at it that the coordinates should have enough precision, enough significant figures. So really, one significant figure is way too imprecise. Two significant figure as well. So try to put at least three or four significant figure. But most importantly, y1 and y2 must have the same dp. X1 and x2 must have the same dp. Okay, so now let's look at the x value first. So this one is written as 0.380, this one is written as 0.075. So now that's fine. Okay, 0.380 is 3sf, 0.075 is 2sf, but 0.380 is 3 dp, so 0.075 is also 3 dp. So now I have x1, x2, same dp, that's fine. Now let's look at y1, y2. uh, y1 is 1. 1 is not precise enough. So we should put something like at least 1.00. Okay, so this should have been written to 1.00. So this is 3SF. So this one should also be written to 2.40. So at least it's 3SF. And now both of them also has the same DP. So that is fine. Okay. And then when we transfer here, it should be 2.40 minus 1.00. Not like that. Okay. So with this, we calculate the gradient, all this kind of thing, and then we get this value here, 0.183. Now, many students did not write down the unit for P. P and Q both have unit. You need to ascertain what is a unit. I can assure you, if P and Q has unit, and in your final answer you did not write the unit, you have to be penalized. Okay, so this is very important. So work out the unit. So how do you work out the unit? The unit of 1 over t square is per second square. Okay, so what about this one? So it equals to the unit of k, unit of p, unit of x. Now unit of k is already written here. Okay, unit of k is Newton per meter. Unit of x is meter. So what then is the unit of p? Let's cancel this. So unit of p will be equals to s to the power of minus 2 and the power of minus 1, because I bring this n over. So that's how you work it out. S to the power of minus 2 and to the power of minus 1. Okay, now let's look at the significant figure. So I put my p to 3sf, 0.183. Is it okay? Now how did I calculate this p? I put kp equals to 4.590. So p equals to 4.590 over 25. Now 25 is the uh, least precise. So my final answer, 25 is 2SF. So my final answer should be either 2SF or 3SF. So I leave my final answer to be 3SF. That is okay, no problem. Okay, but if I leave my final answer to 4SF, that'll be wrong. If I leave my answer to 2SF, that's fine. Okay, now let's look at the next one. Can you see what is the huge mistake that is made here? Huge mistake. This mistake, if you do this, you'll be marked wrong straight away. Substitute 0.4, 0.400 and 2.50, and then this equation and k into the equation. So the substitution is all listed, so that's fantastic. But there's something wrong here. What is this? This zero point 0.4 and 2.5 is not taken from the graph. This is taken from the table. Okay, this is taken from the table. This is a huge mistake. You cannot take the data from the table. Okay, you cannot do that. This data you must take from the graph. So which part of the graph you take from? You've already written two coordinates one. So please take either this one or that one. Okay, and then substitute in and then you get the answer. Okay, so my final answer listed as 0.2656. Okay, uh, is there a problem? Oh, there is a problem because minimum is 25. I mean, the least SF is 25, so which is 2 SF. So this one should be maximum of 3 SF. Okay, so it is 0. I mean, if I sub in the correct value, it should be 0.0262. Okay, so that's that. I'll show you the model answer for this one in the next slide. Now let's look at this part E. Now, this is also very important. This is only 1 mark. Okay, the thing about practical is that you have to fulfill many points to score that 1 mark. Okay, missing any of the 1 point, you will not get the 1 mark. So don't think that the final answer looks correct, you get the mark. No, it's not that. Because for practical, we look at the process. What is the question here? The mark on the sticky paper indicates the position of the meter rule's center of gravity. When the string loop is placed at the center of gravity, use your value from D to determine the value of determine the period of T. So what they mean in this sentence, it means that X is at the center of gravity, so X equals to 0.000 meter. So you have to write down this, okay, that you recognize from this, it means to consider X to be 0.000 meter, and therefore you show your substitution into the equation. Okay, you show your substitution into the equation where this is the equation 1 over t square equals to kpx plus kq. So 1 over t square equals to kpx plus kq. Okay, and since x equals to 0, okay, show the substitution 1 over t square equals to kp 0 plus kq. Therefore, 1 over t square equals to kq. Therefore, therefore t equals to 1 over square root kq, and t equals to substitute in the value, okay, including the correct value of q inside, you get this. Answer is 1.23 seconds. So do not just put the formula, no substitution, and write in the final answer. You will be penalized. So this is practical. Every data, okay, the thought process, the data, everything has to be listed down to score the marks. Okay, so that is that for the marking of this. So now let's show you again the model answer with all the annotation. This will be uploaded so you can study this at your own time. Okay, so look at the first page. Measure and record X. So it has to be written in that manner: X1, X2, X average, and the final value. Okay, you can write it in terms of cm, you can write it in terms of mm, you can write it in terms of meter. It's up to you. Okay, it for this part it does not have to be exactly the same as the later. Even if you later you put meter, that's fine. So because, well, 5.0 cm is equal to 0.050 meters. Okay, now estimate the percentage uncertainty. So once again, you need to write down the equation, and then write down the substitution, and it has to be a judgment. Do not write any equation. Okay, it should be 3 to 5 times the precision at ideal case for this experiment when it is just challenging, but it's not very challenging. Next time you'll be doing some experiment where it is very challenging and delta x could be even 10 to 20 times of the ideal precision, but we'll discuss more of that when we do that kind of experiment. So finally, the percentage error must be written to 1 or 2 SF. Okay, if you write to 3 SF, you will be penalized. If there's no unit, which is percent, you will be penalized. Okay, so look at my presentation here. let the oscillation time for 20 seconds be small t. So it is very clear what small t is and what the number of oscillation is. It's very clear that this 20 is the number of oscillation. So my final answer is 1.04 seconds. So once again, there have been some students who have brought out that, oh, let's look at this equation. 20.8 plus 20.7 divided by 20. 20 is 1 or 2 SF. So the final answer could be written to 1 to 2 SF. No, because 20, there is no error associated to the counting of the oscillation. Okay, so since there's no error associated to n, you don't consider the SF of n. So what is the final answer? 3SF. You only consider the SF of T1 and T2, which is 3. So your period must be 3SF or maximum 4SF. Now let's look at this one. So this sentence is written there because n is not defined in the question. T is not defined in the question. So you have to define everything that you introduce, okay, into the predicator. So you can see here raw data recorded to correct DP for the whole column. Okay, so T1, T2 is also raw data. Now, T and 1 over T squared are called processed or calculated data. So we look at the SF, not the DP. Okay, and now everything else, these 6 points are important. So please look through the 6 points. Okay, so these are the correct answer. We have to explicitly write down plot what versus what is the gradient, what is the y-intercept, and when you calculate the gradient, these have to be written to the exact dp as they are presented on the graph paper. When we substitute the coordinates in for the calculation, it has to be one of the two coordinates on the graph paper, okay, which is where the triangle hits the line of best fit. Units are essential, it has to be written. Okay, and for part E, yes, we have to write down what does this sentence mean. If the loop is placed on CG, it means that x is equal to 0.000 meter. Write down the whole equation and the substitution and the calculation. And finally, the answer must be written to 2 or 3 SF because for this calculation, the least precise is the number 25. Okay, 25 is 2 SF. So T must be written to 2 or 3 SF. Okay, and then this is the graph. Uh, as you can see, the axis is labeled correctly with the unit. Okay, yeah. So all these are just labeling. Okay, so you don't have to bother whether they are the correct SF or DP. Those are not important because they are just labeling. But this coordinate have to be written and used. So is this a line of best fit? Now let me see. I have 6 plots. So 1, 2, 3, 4, 5, 6. Oh, sorry, there's one more plot here. So what do I have? I have 2 plots on the line. Okay, I have 2 plots below the line, 2 plots above the line. So you can see the symmetry there. None of them is anomalous. So this is a valid line of best fit. Okay, and so that is that. We will upload this exemplar on the practical section of the Google site. So that's all for this presentation. Thank you very much.